In this next part of 5.3, we're going to be talking about the derivative of an inverse function, specifically at a point. Let's look ahead to some examples we're going to be working. Find f inverse prime of a. What for the function f of x? So we're given f of x, and this is saying find the derivative, that's the prime, find the derivative of the inverse of f of x at x equals a. That's the value that gets plugged in is an x value. So what does that mean? We have to find the inverse function. We have to find then the derivative of it. Okay, so let's look at possibly what we could do. I'm going to say we could do this because there are some options that we'll have, and I want to talk about why we have those options. So here's what we could do. Find the inverse so that we can take the derivative of it. Well, remember what inverse is. So I'm going to write this differently. I'm going to say we could find the inverse first. So switching the x and y, x equals y squared plus 3. Okay, then we could find the derivative. So what does that mean? Derivative of x is 1. Derivative of y squared is 2y dy dx. Derivative of 3 is 0. Okay, let's get dy dx by itself. That's negligible, and doesn't, 0. Divide by 2y, so there we've got 2y. Well, we want the derivative at the x value that we're plugging in. Well, what is this? This is 19 is the x value, but the x value for what? We've got two different functions here. We have f of x, and we have the inverse of f of x. Well, they're saying plug this value into the inverse function. So x is 19, but it's 19 for f inverse. What does that mean when we want the y value to plug into our function? Because this right here, this is the dy dx for f inverse. This is the derivative of f inverse. This is our dy dx for f inverse. And I'm plugging in the y that goes for f inverse, and all I have right now is the x for f inverse. Well, I could, from my inverse, figure out what the y is when I have the x. So we could do that here. If the x is 19, remember the x is 19, I could say 19 equals y squared plus 3. Solve for the y. So subtract 3, 19 becomes 16 equals y squared, so y equals 4. So now I've got the y coordinate for here. So dy dx is 1 over 2 times 4, or 1 over 8. So finally, f inverse derivative at the 19 equals 1 over 8. But let's talk about some options, because we actually don't have to go through the process of finding the inverse just because we need the derivative of the inverse. Let's go back and talk about what does derivative mean. Slope. What is slope? Change in y over change in x. Well, what's slope of f inverse? Well, what's f inverse? Switch the x and the y. So what's the slope of f inverse? Switch the x and the y, delta x over delta y. I want you to think about this fact that we're switching x and y and the derivative. So off to the side, we're just going to explore something briefly, and then we'll come back to our problem that we're talking about. So step 1, I'm going to give you a function, call it x cubed. I want you to help me plug in 2 cubed. That's right, it's 8. So on the graph of f, we have the point 2, 8. That's the x, that's the y. Okay, let's go to the function that will be its inverse. Let's say g equals the inverse of f. So let's find the inverse. A quick way is to say the inverse process of cube is cube root. So let's write g as the cubed root, or x to the 1/3. I would like you to help me plug in 8 into g. What do we get? Cubed root of 8 is 2. So we get 2. 8 comma 2 is a point on the inverse graph. That makes sense because that's the x and y switched. Okay, now let's look at the derivatives of each. F prime, what's the derivative of x cubed? 3x squared. Let's plug in the value of x that we plugged in to our function f. So f prime of 2, I'm going to give myself a little bit more room over here. F prime of 2 is 3 times 2 squared, or 12. Okay, let's take a look at g's derivative, or the inverse's derivative. So the derivative of x to the 1/3 is 1/3 x to the negative 2/3, or that's better written as 1/3 x to the 2/3. That's easier to work with than negative exponents. Okay, let's go ahead and plug in the x value that we plugged into g. So g prime of 8 equals 1/3 times 8 to the 2/3. How do we do that? 8 cubed root is 2. Cubed root of 8 is 2. 2 squared is 4. So we have 1/3 times 4, or 1/12. What do you notice about our two derivatives? 12 and 1/12. That's right, they're reciprocals of each other. So the reciprocal, and that makes sense, delta y delta x changes into delta x over delta y. The derivatives are reciprocals of each other. So let's see how that can help us make the process of finding the derivative of the inverse at a point a little bit easier. So we could do it this way, or we could do it without finding the inverse. So how does that work? Well, we know that the derivatives are reciprocals of each other. So we can find the derivative and do the reciprocal. So if I'm starting with f, which is x squared plus 3, and I do its derivative. So f prime is 2x. Well, remember that we are plugging in the x value that they gave us, 19, but into the inverse. So that's not really the x value that we want for f. So let's just review a second what they gave us here. So 19, x equals 19 on the inverse function. That's the value that's being plugged into f inverse. That means that y is the 19 on the original function, right? Switch the x and y. So what is the x that we need to plug in to the original function? Let's find it. If y is 19, let's go back up here and say 19 equals x squared plus 3. Therefore, x equals 4. Remember how we had to do that here because we needed the other value to plug into our derivative? Same deal here. We need the other value to plug into our derivative. So now we can plug it in. F prime of 4, 2 times 4, that makes 8. So 8 is the derivative of the original function. Therefore, if I want f inverse derivative at the 19, the value for x that's on f inverse, I just want the reciprocal of 8, 1/8. So if you notice, we didn't have to find the inverse, and it took us a few steps, not as many steps as the other way. So obviously you have choices, but the point is you understand that the derivative of the inverse is the reciprocal of the derivative of the original function. So you have options of how to do it. Personally, I always choose the more efficient, the faster method. Let's do it again with this process. So choosing the faster method, f of x equals sine x. Ultimately, what do we want? f inverse derivative at, what is the value they gave us? Square root of 3 over 2. So knowing that I'm going to need the other value because I'm only working with f and not f inverse, I'm thinking to myself, x equals square root of 3 over 2 for f inverse. What is the x value for f? Because I only want to work with f. Well, if this is the x value, this is the y value for f. So I'm thinking back to f. I'm thinking back to the f function from the inverse function. So if y is square root of 3 over 2, what is the x? Well, if y equals sine of x, y equals sine of x, then square root of 3 over 2 equals sine of x. So what does x equal? That's right, pi over 3. So just to clarify, on the inverse function, so for f inverse, the point is square root of 3 over 2, and we didn't yet know the y. On the f function, the x that we just found is pi over 3. The y coordinate was square root of 3 over 2. So that can take us back to, on the inverse function, the y is pi over 3. Remember, switch the x and y. So now I don't need the inverse. I just need the derivative. F prime of x is cosine x. F prime of the x coordinate on my f graph, this is f, is pi over 3. Cosine of pi over 3 is 1/2. Now I want to say, what is the inverse derivative at its x value, square root of 3 over 2, and I just have to take the reciprocal of this, 2. So let's talk about some steps that we did to help clarify the work that you have to do. So some things to remember. If I want to go through the process of finding the derivative of an inverse function at a point, so just to put this into words, well, you saw the directions. We'll put it into words. So this is the derivative of the inverse at a value. Okay, so to find that, and specifically without finding the inverse, because sometimes that can be easier, sometimes that can be faster. First thing we did, find the x value for f of x. So how did we do that? F of x equals that value they gave us to plug into the derivative and solve for x. Second, all we had to do next, find the derivative of the function, not even the inverse. Then we plugged in the x value that we found in step 1 to our derivative. And then we remembered that inverses, derivatives, are reciprocals of each other. So we flipped over the value. Now again, I'm just trying to give you some options, not necessarily say that this is the way that it has to be done. Remember, in the first problem, we had some options. We can find the inverse, or we don't have to find the inverse. Let's take a look at a similar problem, but kind of the directions are given slightly differently. Find dy dx at the point 2, 3 if x equals y cubed minus 5y squared plus 1. Maybe you pause the video, try it a way you want to, come back and see if you're correct. So let's see what we could do here. We could find dy dx. So straight from here, 1 equals 3y squared. Dy dx, we have to remember to use the chain rule, 10y dy dx plus 0. Let's see, we need dy dx, so I'm going to collect my dy dx terms and factor. So dy dx factored out of 3y squared minus 10y. Divide by that, and dy dx equals 1 over 3y squared minus 10y. So what we want is dy dx at the point 2, 3. That's what it said, the point 2, 3. So I'm plugging in the y value, because that's what I have in there, into, oops, plugging in the y into where I see y. And I get negative 1/3. What's another way that we could have done this? So I'm going to call this way 1. Let's talk about another option, way 2. If I, instead of right away finding the derivative, I go ahead and find the inverse, why is that good? Why would I bother finding the inverse? So I switch the x and y, and why is this good? Well, first of all, I don't have to take the derivative implicitly. I do dy dx, and my derivative is faster. 3x squared minus 15x. Oops, what did I write differently? Oh, I see it. This should be x squared. 5x squared. So that should be a derivative that says 10x. So derivative is faster with this way. I found the inverse first, then I took the derivative. Well, now I have to be careful because I found the inverse. So what does that mean for the point I'm plugging in? It's not 2, 3. Now it's 3, 2, because this is the derivative of the inverse. Switch the x and y. So I plug into here that x coordinate 3, 3 squared minus 10 times 3, and I get negative 3. Well, my answer is not negative 3 because this is the derivative of the inverse. I want the derivative of that original function. So way 2 was when I find f inverse. So finding f inverse, now I have to go back to f, but that's not difficult. The derivatives are just reciprocals of each other. So negative 1/3. There we go. Pick the way that you like.